In this section, we'll discuss the rectangular coordinate system. We'll use the distance formula to compute distances between 2 points, use the midpoint formula to find the midpoint of a segment, and we'll graph equations by plotting points, and finally identifying the x and y-intercepts of a graph. Let's start with the rectangular coordinate system. The rectangular coordinate system is based on points in the form of x comma y. Now it has to be in a certain order, so we call these points ordered pairs. And so if we have a point in the plane that is x comma y, means you go out x units on the x-axis and up y units on the y-axis, and wherever those meet, that's the point x comma y. There's a special point where the axes meet, and that is called the origin. It's the point where the x and y axes meet. And of course that is the point 0, 0. The rectangular coordinate system is broken up into 4 pieces called quadrants. And the quadrants are labeled using capital Roman numerals. And so they are quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Finally, the rectangular coordinate system is also called the Cartesian plane, or the Cartesian coordinate system. It is named after Rene Descartes. Rene Descartes was a French philosopher and mathematician who lived in the 17th century. In philosophy, he is perhaps best known for his phrase, "I think, therefore I am." In mathematics, he developed analytic geometry, which is a way of using algebraic techniques to think about geometry problems, including lines, circles, and conic sections like the parabola, ellipse, and hyperbola. In addition, he also established much of the notation that we take for granted in algebra today. He started the convention of representing unknown quantities with letters from the end of the alphabet, namely X, Y, and Z, and using letters at the beginning of the alphabet for quantities that were known, like A, B, and C. Also, he was the first mathematician to represent powers of numbers and variables as superscripts, like x squared with a 2 as a superscript of the x. Let's look at the distance formula. We're going to develop the distance formula between these 2 points. So let's label the graph with point A, and it's common notation to label points with capital letters, and then we can put the coordinates of the point in parentheses here, and we don't know it, but we're going to do it in general. So it's x1, y1, and the 1 on both the x and the y is a subscript. It goes below. It is not a power. It just represents the first x and the first y. The other point will be capital B, and that'll be the point x2, comma y2. And then let's say that the distance from A to B is D. Now, to find the distance formula, to develop it, we're going to draw an extra point. I'm going to find that extra point by drawing straight across from where A is, and then straight down from where B is. And where those 2 lines meet is point C. And now to find the coordinates for point C, notice that point C and point B are all on the same x line. So the x-coordinate for point C is x2, and the points A and C are both on the same horizontal line, so they both have the same y-coordinate, which is y1. Next, we want to find the lengths of each of these segments and recognize that we in fact have a right triangle. If I start on the segment that goes from A to C, we know that the distance from A to C is the difference in the x-coordinates for those 2 points. Because we're doing distance, we need to make sure that it's positive, so we use absolute value. So we have x1 minus x2 in absolute value. We do the same thing for the y-coordinate, and we find the distance between B and C. So that is the difference between the 2 y-coordinates of B and C. And again, we put that in absolute value to ensure that the distance is positive. Now we can develop the distance formula using the Pythagorean theorem. So the hypotenuse is d squared, and then we need to take the square of the 2 sides. So that would be the absolute value of x1 minus x2, quantity squared, plus the distance on the other leg, absolute value of y1 minus y2, quantity squared. And then the last step is to take the square root. So the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. You may have noticed that I didn't write the absolute value bars this time. That's because we know when we take the absolute value, we end up with a positive number. You will also end up with a positive number when you square the difference. So the absolute value bars are not necessary. Let's take a look at example 1. Find the distance between the points A, which is 5, 1, and B, 9, negative 2. So I'll start by writing the distance formula. D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. I'm going to let point A be the first point and point B be the second point, and that's where I'll get x1, x2, y1, and y2. So the distance is the square root of 5 minus 9 squared plus, now the difference in the y's, 1 minus negative 2 squared. 5 minus 9 is negative 4, so we have the square root of negative 4 squared plus 1 minus negative 2 is positive 3, so that's positive 3 squared. Negative 4 squared is positive 16. 3 squared is positive 9. 16 plus 9 is 25, and the square root of 25 is 5. So the distance between points A and B is 5. Let's take a look at example 2. Find the distance between the points P, negative 2, 5, and Q, negative 1, 7. So we have D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Again, I'll designate P as the first point and Q as the second point. The distance is the square root of negative 2 minus negative 1 squared plus 5 minus 7 squared this is equal to negative 2 minus negative 1 is negative 1, so that's negative 1 squared, plus 5 minus 7 is negative 2 squared, and then negative 1 squared is 1, negative 2 squared is 4, 1 plus 4 is 5, that's the square root of 5. That does not simplify, so that is the distance. Let's look at example 3. The vertices of a square are 1, 3, 4, 2, 3, negative 1, and the origin. We need to find the length of the side of the square, the area of the square, and the perimeter of the square. I'm going to start by labeling each of these points. I'll label the origin A, and then just B, C, and D going around the square. The easiest one to find the length of the square is to find the distance from point A to B. Notice the notation that's used whenever you want to specify what 2 points you're finding the distance between. It's D, and then in parentheses, 1 point, comma, the other point. This is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared, square root of that. Now A is the origin. So all the points we're going to put in for A are zeros, and B is the point 1, 3. I'm going to let B be the first point and A be the second point. So that gives me a distance that's equal to the square root of the x-coordinate from B, which is 1, minus 0 squared, plus the y-coordinate for B, which is 3, minus the y-coordinate from A, 0, squared. This gives me the square root of 1 squared plus 3 squared that's equal to the square root of 1 plus 9, which is the square root of 10. The square root of 10 does not simplify, so that is the length of the side of the square. Part B was to find the area of the square. We know that area of a square is equal to the side squared. The side length is the square root of 10, so I have this is equal to parentheses square root of 10 squared, which is just equal to 10. So the area of the square is 10 square units. And part C was to find the perimeter of the square. The perimeter of the square is 4 times the side length, and so that is just 4 times the square root of 10. Next, let's look at the midpoint formula. Again, we will derive the formula. So let's start by labeling the points A, x1, y1, and B, x2, y2. The midpoint of a segment is the point in the exact center. We call that M. And the formula for M is simply found by taking the average of the two x-coordinates. So that would be x1 plus x2 divided by 2, and by taking the average of the y-coordinates. That's y1 plus y2 over 2. The answer is a point itself, so we need to write it as an ordered pair. In example 4, find the midpoint between P, -7, 4, and Q, 9, 15. So M is the midpoint, and we just average the x-coordinates, so it's -7 plus 9 over 2, and the y-coordinates, 4 plus 15 over 2. This gives us 2 over 2 and 19 over 2. We'll simplify the 2 over 2 to 1, but 19 over 2 we can leave. Let's take a look at graphing equations by plotting points. So the first thing to note is a solution to an equation with x and y is an ordered pair that satisfies the equation. In other words, you should be able to check the x and the y in the equation and make sure that both sides are equal. In example 5, it says show that 1, 4 is a solution to the equation 2x minus y equals -2. So we'll just check 1, 4 in the equation 2x minus y equals -2. So we have 2 times 1 minus 4, and we're doing a check, so we're going to use the special might be equals to symbol, -2. 2 times 1 is 2, minus 4 might be equal to -2. And sure enough, 2 minus 4 is -2. That is equal to -2, so this one checks out. So 1, 4 is a solution to 2x minus y equals -2. Now when we graph an equation, what we are doing is supplying a visual representation of all the points that do work. We're finding all of the solutions. In example 6, we want to graph y is equal to x squared by plotting points and then connecting the points. So here we have a table of values. The x values are given, and then we will find the y values by plugging them into the equation. When x is equal to -3, we take -3 squared to find y. -3 squared is +9. So one solution to this equation is -3, 9. To find the other solutions from the table, we just square the x value, and that gives us the y value. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. These, in turn, are now points to graph on the graph next to the table. So we're going to have -3, 9, -2, 4, -1, 1, 0, 0, the origin, 1, 1, 2, 4, and 3, 9. And then we connect the dots in a smooth curve. And you may remember that this is the graph of the parabola. Let's look at example 7. Graph x minus the absolute value of y is equal to 0 by plotting points. What we're going to do is we're going to use the table of values that are given, but first I'm going to rewrite this equation so that x is alone on the left side by itself. That means moving the absolute value of y to the other side. When we do, it moves over as a positive. Now we've been given the values for y to use, and we'll plug those into the absolute value and find the values for x for each value of y. So when y is equal to -3, the absolute value of -3 is +3. So we get the point 3, -3. And we'll do the same thing with the other y values. The absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. And the absolute value of 3 is 3. Now to graph this equation, we just graph all of these points. So we have 3, -3. So we go over 3 on the x-axis, and down 3 on the y-axis. We have 2, -2. We have 1, -1. 0, 0, the origin. 1, 1, 2, 2, 3, 3. And from this we can extrapolate what the other points would be. This forms a straight line on top and a straight line on bottom. And it meets the corners. So that would be the graph of x minus the absolute value of y equals 0. Finally, let's identify x and y intercepts. First, the definition. An x-intercept is a point where the graph intersects the x-axis. So the x-intercept is a point where the graph intersects the x-axis. That means that the y-coordinate is equal to 0. Because remember, the x-axis is where y is measured from, so that's y equals 0. In turn, the y-intercept is the point where the graph intersects the y-axis. And the y-axis, of course, is where x equals 0. So one thing to remember, if you're looking for a certain intercept, then the other variable must be equal to 0. So if you want the x-intercept, then you set y equal to 0. If you want the y-intercept, you set x equal to 0. In example 8, find the intercepts of y equals the absolute value of 2x minus 4 minus 6. When it says find the intercepts, it means both the x and the y. Let's start with the x. So the x-intercepts are when y is equal to 0. So I'm simply going to substitute y equals 0 and solve for x. So we get 0 is equal to the absolute value of 2x minus 4 minus 6. I'm going to move the 6 to the left, so we get 6 is equal to the absolute value of 2x minus 4. To solve this absolute value equation, we're going to split it up. And I'm going to write it as 2x minus 4 equals 6, and 2x minus 4 is equal to negative 6. I'll solve the equation on the left side. So we have 2x is equal to 10 and x is equal to 5. And the equation on the right side would be 2x is equal to negative 2. Dividing by 2, we get x is equal to negative 1. Now remember that the x-intercepts are points where the graph intersects the x-axis. So we need to represent these as points. So the first one, where x is equal to 5, would be written as 5, 0, and the second one would be written as negative 1, 0. Because remember, the y is equal to 0 for the x-intercepts. Let's find the y-intercept. So the y-intercepts are where x is equal to 0. So I'm going to plug in x equals 0 in my equation. So y is equal to the absolute value of 2 times 0 minus 4 minus 6. That's equal to the absolute value of 0 minus 4 minus 6, which is equal to the absolute value of negative 4 minus 6, which is 4 minus 6, which is negative 2. The y-intercept is also a point, so we write this as 0, comma, negative 2.